It is January 23rd, 2026. We're coming off a record-smashing run of heat, and on this map you can literally see 2024 lighting up the planet. 2024 was very likely the first calendar year to average above 1.5 degrees Celsius over pre-industrial, and 2025 barely stepped back. The question is simple. Did we just lose the Paris Agreement's 1.5 degrees Celsius goal? Here's our roadmap on screen. First, what a 1.5 degrees breach actually means. Then, the race between clean power growth and the carbon we've already loaded into the system. Then, heat, food and water. Finally, what that implies for 2030. Let's get straight to the audit. Scientist Copernicus puts 2024 at about 1.60 degrees Celsius above the 1850 to 1900 baseline. That sounds like a failure of our climate goals. Is it?
Not officially. Paris is about a long-term level of warming, not a single hot year. So it's assessed using multi-decadal averages, often around 20 years. On the chart, that's the difference between the jagged year-to-year line and the smoother trend.
So 2024 was a spike on top of a rising baseline.
Exactly. Think of it like a fever. One day is a spike, a sustained shift is the new normal. 2024 was a fever year, but the worrying part is how high the baseline has climbed.
And the cool down didn't buy us much. Copernicus says 2025 averaged about 1.47 degrees Celsius above 1850 to 1900. Still the third warmest year on record, just 0.13 degrees Celsius below 2024, and essentially tied with 2023. You can see how tight those top three bars are.
So even a cooler year now still lands in the top tier of all-time heat.
That's the danger. Copernicus also finds the 2023-2025 three-year average has now edged above 1.5 degrees Celsius, while other consolidated estimates sit right around that line. Either way, we're on the rumble strips.
So welcome to the Overshoot era. The trend line keeps rising, and the spikes ride on top of it.
Precisely. The margin for error is gone. Every tenth of a degree from here scales the risk, and you don't need a new record to feel the consequences.
If you look strictly at the construction sites, we're building a clean power system at breakneck speed. In 2024 alone, the world added about 585 gigawatts of renewable power capacity. And it wasn't just a good year. Irina says renewables made up about 92.5% of all new power capacity added globally in 2024, driven mostly by solar, with wind close behind.
So, the fossil fuel era is effectively over in the construction sector.
For new capacity, it's getting close. And you can see the shift in generation too. In the US, wind and solar produced more electricity than coal for the first time in 2024. In the EU, wind and solar edged past fossil fuels in 2025.
But here is the disconnect. If we are building clean power at record speed, why did Dr. Aris just tell us temperatures are still rising?
Because electricity isn't the whole economy, and even the grid is growing. Heat, cooling, data centers, electrification. Demand keeps climbing.
Exactly. Cooling demand is surging, and every record-hot year pushes peak electricity use higher.
So the headline still stings. The IEA estimates energy-related CO2 emissions rose about 0.8% in 2024 to a record 37.8 gigatons. Solar is winning on cost and speed. But we only win the climate math when fossil fuel use actually drops. If coal and gas plants keep running to cover peaks and gaps, emissions don't fall.
What about technology that removes the damage? We hear about carbon capture and direct air capture. Can't that clean up the mess?
Those technologies are real, but right now they're small. They can help in hard-to-abate sectors, but they can't replace cutting emissions.
And the physics are unforgiving. Separating CO2 takes energy. The easiest ton to deal with is still the ton you never emit.
Look at the scale. Globally, operating carbon capture capacity is a little over 50 million tons of CO2 per year, against 37.8 billion tons emitted in 2024. That's about 1/10 of 1%.
So it's a rounding error.
For now. Projects like Denmark's green sand storage and Iceland's mammoth direct air capture plant are impressive proof points. But they're still early and tiny compared to the global total. To make a real dent, capture would have to grow from tens of millions to many billions of tons per year, hundreds of times bigger. That's a massive industrial build-out.
So the verdict on tech?
Solar and wind are ready to carry real load today. Carbon capture is a targeted tool for the hardest emissions, not a near-term plan we can wait on.
When people ask what the overshoot era feels like, it's not a chart. It's what the triptych on screen is showing. 3 pressures you feel in daily life: dangerous heat, volatile food, and water swinging between too much and too little. And they compound. Heat stresses water, water constrains food, and food shocks hit health and economies.
Let's start on the heat panel. 2024 was the hottest year on record, and 2025 stayed in the top 3. Is the main risk just discomfort or a public health crisis?
It's a public health crisis. The Lancet Countdown reports heat-related mortality rates are up 23% since the 1990s, about 546,000 deaths a year on average in the most recent decade of data. And in 2024, climate change added roughly 16 days of dangerous heat exposure for the average person. The danger isn't only the peak, it's humid air and nights that don't cool down.
That's the trap my sector keeps running into. To survive the heat, people buy air conditioning fast. But every new unit raises electricity demand, and if that power is still fossil heavy, we're burning more fuel to cope with warming caused by fuel.
That leads straight to food. If crops are baking in that same heat, are we headed for global shortages?
The bigger risk is volatility, not an empty planet. As of the latest UN estimates, about 673 million people faced hunger in 2024, and climate shocks make that baseline harder to move. In southern Africa, drought linked to El Niño conditions hammered maize in some places. Zambia reported losses on the order of half the planted area. At the same time, intense flooding across parts of the Sahel and the Lake Chad region inundated farmland and damaged harvests in places that were already fragile.
And volatility is an inflation story. When a breadbasket region gets hit, prices move everywhere, fast. It doesn't matter if there's grain in a warehouse, if households can't afford it at the checkout.
Which brings us to water. You've described floods in the Sahel and drought farther south. So is the problem too much water or too little?
Both, sometimes in the same basin, in the same year. That water whiplash graphic is literal. The water cycle is getting more erratic. WMO's 2024 assessment found only about 1/3 of global river basins were in normal conditions. Most were running unusually high or unusually low. Water is the hidden multiplier. It sets the heat risk, it sets the harvest, and it can shut down energy, from hydropower to power plant cooling.
So, the big question, is this manageable, or are we just living in reaction mode now?
Manageable, but not easy. And it has to be systems, not slogans. Early warning systems work. Countries with strong coverage see disaster mortality at least 6 times lower. Then it's the unglamorous work. Cooler cities, safer housing, resilient grids, crop varieties, and water storage that match new extremes. The physics isn't negotiable, but the outcomes still are.
We've looked at the heat records and the solar boom. Now let's talk bottom line. Where does this trajectory put us by 2100? Dr. Aris, using UNEP's latest emissions gap numbers from late 2025, what warming are we actually heading for?
On the chart, UNEP's current policies pathway centers around about 2.8 degrees Celsius of warming over this century. If countries fully deliver their latest NDCs, UNEP puts us closer to about 2.3 to 2.5 degrees Celsius. Better, but still well above the Paris target.
And that spread is why 2030 matters. To stay on a 1.5 degrees Celsius consistent track, global emissions need to fall by around 40% by 2030, compared to 2019. Under current policies, UNEP has 2030 emissions at roughly 57 gigatons of CO2 equivalent. A 1.5 degrees Celsius pathway is in the low 30s, roughly the mid-30s at most. That gap is what we have to close this decade.
That sounds impossible. So is the verdict that this is a crisis, or is it still manageable?
It's both. Manageable in terms of physics. The peak temperature is still a choice, but a crisis of governance and pace. This is what people mean by the overshoot era. We are now likely to breach 1.5 degrees Celsius in near-term averages. The question isn't whether we touch that line, it's how high the peak goes and how quickly we bend it back down. Every fraction of a degree we avoid saves lives.
Exactly. Solar is winning the cost war. But the climate is decided by the construction schedule, grids, storage, transmission, and the speed we replace coal, not just announce targets.
So 2030 isn't a cliff we fall off.
No, it's a pivot point. If we miss 2030, we don't give up, but we do push ourselves toward a world that bets on massive carbon removal later, at a scale that's still uncertain and risky.
Dr. Aris, final word, what is the one thing we must accept in 2026?
That adaptation is no longer optional. The ocean's heat and the sea level rise already in the pipeline don't reset on political timelines. Some of it is effectively committed for centuries. We have to protect people while we cut emissions.
So we didn't hit a wall in 2024. We crossed a line that tells us the margin for error is gone, even as clean power ramps up. This is the overshoot era. It's not game over, but the game has definitely changed. Thanks for listening.